Why data structures? So, as I said, like companies do this, especially big tech companies. Generally, startups or mid-level companies don't do this in general. They prefer asking the questions related to the post that they are hiring. But tech companies do like follow this procedure of asking data structure and algorithm questions in their interview. And there are multiple reasons why people find it wrong. And I have listed down a couple of them, which I would like to discuss today. So one of the first points is that, many great candidates don't do good in these interviews. So, and that is true. Like, for example, since you guys have been, second or third year of college, many of you have started doing this, that instead of sitting at home and doing lead code or code forces, you guys went out, you guys experienced multiple new tech stacks that are coming in the market. You guys did your internships, you guys gained a lot of experience. And if you continuously keep learning about a particular tech for 1 to 2 years, you get pretty good at it. So by the time you reach in your 4th year of college, or even if you're working as a working professional, if you're a working professional, then also you guys do have great development skills. But still, due to this data structure and algorithm thing, you guys might get rejected in the interview. That is a fair chance, because someone who has been just grinding about data structures from their 1st year of college will definitely do better in data structure and algorithm. That's just how it is. So due to this, many great candidates who would be great developers might miss out on working in these companies because of this. So seeing it from the company's perspective, what I would say is that, there are a company does not see how a candidate does. For a company, it does not matter. It does matter, but a company can handle that they don't hire a few good people, because a company has set out its path that it will grow itself along with multiple good candidates. So definitely they will miss out on some of the people who are actually very good in interviews. So how can we, so talking from their perspective, what they do, they want to optimize this. They want to reduce the number of candidates who are actually good, but only getting rejected because of DSAs. But there are some people who do the opposite. For example, they have only did lead code and code forces in all their 4 years of colleges. They will perform very well in the interviews. But when it comes to, performing in actual development environment, when they, for example, they cleared the interview and they got into their jobs, then what happens is they struggle. They struggle a lot in understanding how each tech works. So a company might lose some great candidates, but they don't want any of these candidates who are very good in interviews, but not good in development. So how do they do this? How do they, filter out these particular students? So this is how, this I will talk more in detail in our in the interview process, how they take their interviews, how they make sure of these things. But for now, it is true that data structure will allow them to, will definitely filter out some good candidates, but companies are quite okay with it. That's just how it is with big companies. The next point is that, in data structures, if you start doing the course, you will realize that we will be focusing more on binary trees, linked lists, graph, etc. And in real world scenarios, for example, when you get into those companies, if you get hired in a big tech company, you will realize that most of your, most of the data structures that you will be working on will only involve array, strings, and hash map, or dictionaries, as they say, multiple languages. So these 3 data structures will, take up 90 to 95% of your time. You will be focusing more on these because they are much more, they're very flexible, and the job that we do in industry can be done using these 3. This is a general case. That's why I have used rarely here. We do use binary tree and linked list in real world scenarios as well. And this is why it is very important to learn binary tree and linked list, so that you could use it in these rare scenarios. But then again, many people might say that we can learn these data structures when and if the time comes. Like for example, if I'm working on a project and I came across a problem statement and I realize that this can be done by binary trees, then I will learn binary tree. It does not take much time. Like if I spend a week on binary tree, I will definitely get good at it. Then why should we learn it right now and not learn at that moment in time? So for this, like there's a very simple answer, which is, for example, you have to know what a binary tree does. You have to know what a linked list does and all of its properties in order for you to know that you need binary tree to solve this problem. For example, someone who does not know addition cannot suddenly go to the market and do 20 plus 20. Like if he knew addition, even if he didn't know addition, but he knew that there's a concept of addition which will help him do 20 and 20, like 20 plus 20, then he would learn addition. But if he doesn't know that there is a concept such as addition which will help him do this, then he will never be able to figure out this. Like he might be able to figure it out, but company cannot extend that much time just for you to learn because you didn't learn something which was already there in your college. So, and you cannot ask these questions on Stack Overflow and other public platforms because, for example, anything that a big tech company is trying to implement, those are very confidential data. You cannot, publicly post that I'm trying to do this and I'm not able to do this. How they should get? You will get your answer, but someone who might know that you are working in Google or Amazon or any other company might take advantage of that situation. So we do not post anything related to our work publicly. So yeah, so basically the point is that you should have the basics of binary tree and linked list clear in order to do this entire process. So that is why they do this. And many people don't. And like I do agree that these points are valid in fact. For example, does anyone here news about homebrew? One second. Does anyone have ever heard about this name before, or just brew for that matter? Basically, it's a very Mac oriented. So for those who are using generally, Windows or Linux or Ubuntu, basically, haven't heard about this, and that's pretty common. But this is basically brew is basically software installer. So if you are using if you want to install a package, let's say let's take any library. Let's say you want to install Java, say. Okay, let's say you want to install OpenJDK. This is a Java development toolkit. Not important right now. Just basically think of it as a library. If you are on Linux, you use apt-get. This is the tool that you use to install a package in Linux. Ubuntu basically, not Linux, Ubuntu. If you are on CentOS, you use yum. These things are not that important, just for your knowledge. I'm just writing these down. For Windows, you can straight away go and download a .exe file and run it. That's one way of doing it. But for Mac, you can use brew. This is for Mac OS. Now the reason I brought this out is there's a very funny story around this. That once Homebrew, the guy who basically who created Brew, interviewed for Google. Okay, and he went for an interview with Google, and they asked him to invert a binary tree. This is a very famous story. I'm pretty sure many people have heard about this. Okay, they asked him to invert a binary tree on a whiteboard. And he wasn't able to do this because obviously, if you're working on some tech which does not involve binary tree for a continuous of 10 to 20 years or maybe more, then you will probably also feel the same way as they did. Like it's very hard for you to invert a binary tree if you don't have the knowledge about them. So on this, there's a very famous tweet. So if I come here. So basically, it says that they tweeted that 90% of our engineers use the software you wrote, Homebrew, but you can't invert a binary tree on a whiteboard. So basically, they don't, they won't consider you. So this is why data structure is very important, because like no matter how much development they will still see it. And I know it's not very fair, but there's nothing we can do about it right now. So it's better to focus on what we have on our plate.